A very special piano has arrived at the shop recently, and I want to share it with you. It is from one of the most important manufacturers in the history of piano making, that of Sebastian Erard. And they are most famed for having invented what became the modern grand piano double escapement action. And this piano has a version of that original double escapement action, which we will take a look at. One aspect of Erard pianos is that once they had designed a good piano and a good action, they stayed with their design to a great deal. And though this piano was built in 1871, it isn't remarkably different from the piano they built in 1854. So, in that respect, this piano reflects a much earlier period of development, but it marks quite a high watermark for that period of development. We'll take a look at the action, but I want to look at some of the engineering at work in this piano. I think the first thing you notice when you look at this piano is that the strings don't cross. That's not so surprising because, up until 1860 or so, it really wasn't done in grand pianos. They thought that keeping each wire smoothly progressing and making a transition from one type of string to the next as smooth as possible. They kept everything as close as possible on the board so that they would have as little a jarring transition as possible. And this piano proves that that's not an unreasonable assumption. But by 1871, this type of stringing had definitely seen its day. But this piano is here to show that it definitely had its day. This piano sounds quite nice. The other point that I would draw your eye to is that the plate is made up of a number of components that are bolted together. There's basically a wrought iron plate that runs the length of the back. That's the hitch pin plate. And then above that are wrought iron struts that are braced between those heavy toggles you can see right there. And see if I can get a view of one here. Similar toggles at the ends of each of the struts. And in that sense, wires are suspended from the front lip of the hitch pin plate. Okay, up here in the extreme base corner, you get down here, you can start to see the plate on edge. See, it's just a thin sheet of wrought iron. And into it are all the hitch pins. Along the front edge of the hitch pin plate are a series of nose bolts and, zoom in on one, spanner nuts. And these pinch the front edge of the plate. And what they do is regulate the position of this iron plate in relationship to the bridge. So the bearing can be set, and between the two of them they keep that from going down or up, because the strings do pull vertically on the wires a little bit. And keeping that hitch pin plate in place are a series of wrought iron struts. And as I said, they are bucking between, over here, the pin block, and at that end they are bracing the plate itself. At the pin block end, the braces bear against these anchors that have been mounted into the front of the pin block, and further anchors underneath this other end, so that that actually fits into a notch in the strut. So it's got to compress the entirety of the strut before it can start to move. At the other end, as you can see, the strut bucks up against a lug that is somehow formed into the plate. Bit of a mystery how that one works, but it seems solid. And if you go forward, following the plate, as you get towards the hitch pin, on the underneath is another one of those nose bolts that controls the height of the plate. And between these, I think these pianos have about 10 tons of pressure on them. Things are held in check. Rather than a difference, this is kind of an important similarity. Those little brass lugs that the strings are passing through, those are an Erard invention. Prior to that, most pianos had a little bridge, a lot like the main bridge in the front, that kept the strings all in their groupings and marked off the speaking lengths. This little creation here was revolutionary and was universally adopted. The last detail I want to share before I move on to the action itself is the dampers. see if I can zoom in and show you this. But the dampers are on the underside of the strings. This underdamper system is, to the best of my knowledge, fairly unique to Erard, and they kept it up. I'm not sure if they ever gave it up, but as you can see, the dampers are pulled down and away from the strings. And this has some implications in the action, so we'll take a look at that now. Okay, this is the famed Erard double escapement action. And as you can see, it really does look an awful lot like a modern grand piano action. For reference, here's your bog standard generic American grand piano action. See, just got the hammer in the same place, got a little repetition lever here, the jack's in the same place, got a kind of whipping body, and the keys roughly in the same place. So yeah, it's clearly the ancestor. And here on the Erard, as you can see again, the hammer facing forward, little round knuckle. There's the repetition balancier, just as on the other one, and it's a little hard to see in there, but there's the jack popping out. In case it couldn't be seen, from the front side is the, there's the jack bumping into the let-off button, just like every standard action. So everything between the front of the key and the tip of the hammer through the mechanics is all pretty standard. Nothing terribly unusual. It's what's going on at this end of the key that is peculiar about this action, and that's because they insisted on having that underdamper system. And because the underdamper requires something to pull down, they had to attach a little lever, this, to the back of the whipping, and that pulls down on the damper block. I guess that makes some sense. But the other limitation was that there's no exposure of the back of the key, so there's no room to have a back check. Here in the standard action model, you can see that the back of the key lifts up on a little lever that in turn raises the damper. And of course, with the back of the key exposed, this system can have a back check mounted. So that little thumb can reach up and grab the tail of the hammer in order to achieve back check. In the Erard system, the back of the key is hidden, so there's no opportunity for a back check. So their solution was to mount a wire, this little item here, to the whipping, so that as the hammer rises up to strike, that little piece of metal rotates forward just far enough to catch the buckskin on the inside of the split shank. The split shank also being a unique feature to these Erard actions. But it provides a space for the buckskin and the back's check to operate. And it's a pretty smooth system. But it didn't survive in evolutionary terms. Another interesting detail of this piano is that there are no bushings in the balance rail mortises. It is just relying on perfectly cut wood. And I think I'm pretty lucky to have these in this condition. It is, of course, the shank that catches your eye the fastest in one of these actions because of this split fork phenomenon. But it has a few other little details that a modern technician might find interesting. It does indeed have a drop screw. Let me get down here where I can see it. The drop screw is a T-bar that, if I can get it to do it here, rotates by half turns. To adjust the drop. And such, and in turn affects the rise. So there's another standard adjustment accomplished in a unique fashion. And this flange up here has me curious. See if I can get some light on it properly. This piano has a rather unique hammer flange. As you can see, it wraps around the pin and bushing, and this upper screw squeezes on it. That would have the effect of controlling how much resistance is in this hinge, and if you can tune that to a nicety, it really helps with repetition, because it makes this section fall just a little slower than the rest of it. And it lets the system send a little more energy back toward the key. It's subtle, but it's part of it. And this, when it's new, I would assume, lets you adjust that quite nicely. Not to leave anything out, this is the inside of the action cavity, and what we can see are at the far end is the shift return spring, a intermediate brace between the pin block and the belly rail, and the damper back action. Get a little closer here on it. You can see it's a series of wires going up. We saw that they had dampers on the tip, and when you press the key, it presses down on that. The complete sustain system is controlled through there, but it is terribly out of regulation and it just isn't really doing it, and I don't want to jam anything, so I'm going to leave it as is until I can take care of it properly. But funny thing about this design is the modern over damper system doesn't take up any more room. So this system was outmoded pretty quickly. But they did a nice job of making it, I'll give them that. Well, I think I've given a pretty good overview of this instrument. The things that make it different and similar to more Bonnard instruments. And the last thing I want to show you is right there. There's the date of the piano, 1872. So, there's a sure place to find the date for these instruments. I'll be digging deeper into this one in time, but I need a very special screwdriver to take it apart, and I haven't made it yet. So when I make the screwdriver, I'll show you more. Thanks for watching.